All right, so we are going to add two vectors again, the same one as the previous example, but now we're going to use a component method. So on the component method, as you can see what I did on the diagram already, delta d1, I broke it into components, delta d1y and delta d1x, just to circle them. And I did the same with delta d2. I broke it into components just graphically, just for us to see. We don't need to do this when we actually solve the problems. And I did the same with the vector sum, or the total displacement in this case. Here is the x and here's a y component. And as you can see, when we use component method, what we do is we can see from the diagram that delta dtx is actually equal to delta d1x plus delta d2x, and delta dy is equal to delta d1y plus delta d2y. So pretty much what can we do in a component method? First, we break down. So I'm going to do it in a chart form. So the steps. So here's a chart. So I have delta d1, delta d2, and delta dt. And what I'm going to do is I use a chart. It helps me a lot to organize my thoughts. So here is the x component and the y component. All right, so it's a better chart. So what we do is we find first, I'm going to write here plus or minus. Remember, depending on which quadrant the vector is, delta d1 times a sine or cosine, depending what angle. In our case, we're going to use cosine, but remember, it depends which angle is given. Delta d2 cosine theta 2. So first we find the components of the vectors that we're adding or subtracting. Delta, this is sine, the y component, sine theta 1. The same with delta d2 cosine theta 2, whatever the angle is, plus or minus, delta d2 sine theta 2. So remember again, in most of the cases, this is how it's going to be. We start the angles measured from east and west, from horizontal axis. But if they're given different ways, make sure that we switch the two trig ratios. All right. So what we do here is we find delta dx by just adding them. Delta d1x plus delta d2x, and then delta dty by just adding them. Delta d1y plus delta d2y. So this is one. And the second one is, now that we have the components, we find the vector, right? So we find the magnitude of delta t by using Pythagorean theorem, delta dtx squared plus delta dy squared. And we find the direction angle by using one of the trig ratios, tan in this case, delta dy over delta dx. All right, so this is how we use the component method, and the benefit for it is it is very straightforward, especially when adding or subtracting more than two vectors, as you probably have already appreciated in grade 11. So let's do our example here. So we continue with our example. All right, so we have delta d1, delta d2, and delta t. These are the vectors. And now we have to remember delta d1 is on the northeast, right? delta D2 is in the southeast or east-south, east-south. So which means here we're going to have both components positive. Here we're going to have the x positive, but the y negative. All right? And then we get the components for our total vector, total displacement, or the net force if we're working with force or velocity, whatever vectors we're adding, right? So let's start with the x component for delta d1 is plus 22 cosine 33 degrees, which turns out to be approximately 18.4 meters. The y component is, again, plus 22 sine 33 degrees, which turns out to be roughly 11.9 meters. And I do the same with the second vector. Again, the x is positive, so plus 11 cosine 28 degrees, which is 9.7 meters, and minus 11 sine 28 degrees, which is negative 5.16 meters. Remember what negative means here. It means that it's on the on the south direction, right? Then all we do is we just add these two up and these two. So we get delta dtx to be positive 28.1 meter and delta dty to be positive 6.74 meters. Those we subtract these two pretty much. All right, so now we have delta dtx plus 28.1 meter and delta dty plus 6.74 meters. So all we have to do now is find the magnitude of delta dt, which is square root of 28.1 squared plus 6.74 squared. So we find delta dt to be roughly 28.9 meters, which is same as other method, right? Because we did get that. And we find the angle by using the inverse tan of delta d ty over delta d dx. And if you do the math, you get roughly 13.5 degrees, which is again the same as the previous method. So we can report delta dt to be approximately 28 or 29 meters, and the direction is east 13.5 degree north, which is exactly the same as before. So when you're adding two vectors, the choice is yours. When you add more than two, the choice is obvious. You should use the component method. I forgot to mention here that when we get the signs in front of the components, we know in what quadrant this is going to be, which is first quadrant, right? Or the northeast quadrant, if we're using compass directions. And that's how we use the component method.